So Ashod Donikian is a founder and CEO of Navisense, and he received his bachelor degree and PhD degree from UTS in 2003 and 2010. Ashod has been working on many important projects, including the 2007 DARPA Urgent Challenge. And after his PhD, he built up his company. He is quite a different graduate from our other graduates. So probably I will let Ash talk about his own journey. Ash, make sure you have you will provide enough time for people to ask your question. Okay.
Yeah, I'll. We have about 40 minutes for the talk and 20 for questions, roughly, right?
Okay, good. Okay, so I will give the time to you now, Ash. Yeah.
Awesome. All right. Well, hi everyone. Great to see some familiar faces and fellow researchers that I worked with many years ago. And thanks for the introduction, Shudong. And as you guys know, my name is Ashod Donikian. I'm the founder and CEO of a company called Navisense. And today, basically, I want to kind of go over a little bit about my journey, originally from a PhD student in Australia at the UTS Robotics Institute. And then kind of going on from there towards focusing on commercializing the technology that I developed during my research, and then starting a tech company and basing that company in the US in San Francisco. So I kind of want to really cover a lot of the things that, given this audience, you'd be interested in. So a little bit about the research side, a little bit about the technology, and the transition towards from a PhD research towards a tech company. And also a lot of the questions I get, especially from an Australian audience, which is, why move to the US? Why base your company in the US and rather than staying in Australia? So covering the transition essentially from research to tech company. All right, so if you look at the state of location technology today in 2021, there's a lot of problems that we get, and even Google and Apple really haven't gotten location right yet. Now, if you look at this image, you'll see a blue trajectory, and that blue trajectory is actually real data, and this screenshot is from our own research platform where we log data, we play that data back, and then we analyze information and focus on improving our algorithms. And you'll see this blue trajectory. If you follow that trajectory, it goes down a street, goes inside a building, as you can see, goes into another building, and then finally it seems to be on a different street. But is this what really happened? Now, if I focus on this next slide, you'll see there's a red trajectory, and that red trajectory is actually data from Navisense. And again, this is real world data, and you'll see that at the beginning, it's actually similarly correlated to GPS. But once the user exits the first building, instead of going across another block into another building and then kind of in between two streets, you'll see that the user is actually on the corner of that street there. So if you imagine today, if you're waiting to pick up a car, whether it's an Uber or Lyft, or if you're a delivery driver delivering food, or if you're just navigating in an unfamiliar city, having the position jumping by a block or more, like you see in this situation, is actually quite problematic. And even today, with the large tech companies and platforms, which include iOS and Android, we still have a lot of these problems. And I want to go through today why we have these problems, what we do differently at Navisense, and how we're solving some of these issues. All right, so introducing Navisense. So Navisense, essentially, we're a hyper-accurate location platform. And our focus is on providing the most advanced location technology that you can get in a smartphone or in wearable devices, so that developers and application builders can power either the next generation of applications or just really improve their existing applications that they have there. And our focus at Navisense is really to be scalable. It's to work in any environment. And that's really one of the key differences, which we'll get into in the next few slides, is we want to be able to work indoors, outdoors, and even underground. And if you think about it, to be successful as a location technology, you really have to work where a lot of the smartphones and mobile devices that users are carrying work. And you'll see here another small image where the blue zigzagging line, this is Google in this case, and you'll see that nice red trajectory, which is Navisense. Now here I'll show you a video so you can kind of get an idea of the location technology and what we're really doing. And this video is also from our research platform that we use to visualize and analyze data. And it's actually sped up quite a bit. So it's a user, you'll see here, basically walking down a staircase. You'll see the green trajectory showing where the path of the user, and that 3D model is essentially the orientation of the smartphone. And this is the actual raw data that we generate from sensor data. And this is why our trajectory, when you look at a lot of the images that I've showed comparing to Google and Apple, is so much smoother. So interestingly here, you can see the staircase there looks staggered. It's not directly vertical. And if you might think that's actually incorrect, but actually the staircase in this building is staggered. So you can see that we can even tell whether the staircase is completely aligned vertically or offset. And now the user is basically going to walk into an elevator and traveling up an elevator. So you can see here, this is the type of detailed information that we generate purely from the smartphone sensors. And this allows us to have a much more accurate picture of what the user is doing. And now we'll slowly get into how we do this and why it's possible for us to do this. So before we get into that though, first of all, a lot of people ask, why do we care about location, or why does location matter? Now, location, in almost every app we use daily now, location is a part of that app. Now, some apps use location without actively showing you, and that might be collecting for advertisements or for targeting you as a user. But there's a huge amount of apps that use location where they rely on knowing where you are, or where a driver or a building or an address is for their service or for efficiency. And what we're seeing the last few years especially, and some of this has fluctuated depending on whether people were staying indoors during the pandemic, and some of this has been replaced with, say, food deliveries. But we see that there's a huge number of rides and deliveries that happen a month. So for example, we see that close to 1 billion different rides happening in ride sharing. And this is data that may have actually increased by the time when I first analyzed this information. And you can see even with scooters, which became very popular in the US, there were huge, millions. So there's tens of millions to billions of rides happening every month. So location accuracy becomes really important for these services to work and for them to work well. And, there's a whole bunch of other applications, video games, or, Pokemon Go is probably one of the biggest ones that relies on location. You have Google Maps that has, at least 1 billion plus monthly active users. So there's a lot of navigation applications. There's Mapbox, which is a mapping SDK or a mapping platform. It's on hundreds of millions of devices. So all of this starts to accumulate into quite a large number of users relying on location every month. And of course, we have deliveries. And, especially with food deliveries increasing a huge amount, and of course, Amazon doing a bunch of deliveries and online ordering. This is just in the US alone. There's billions of deliveries happening. And that doesn't include the amount of deliveries that Amazon is doing, which it does 50% of its own deliveries. So you can see that there's a huge scale where location accuracy not only affects the services and the products that you're using, they're affecting the experience you get as a user, and they're affecting the bottom line and the unit economics of a lot of these companies. So at scale, we're seeing there's huge differences and improvements that you can make. Even with a few percent incremental difference, the impact can be quite large for location. Okay, so then why is location still giving so many problems? If you see some of the details that I've shared and the screenshots that I've shown, it's jumping around quite a lot. Well, it's actually quite a difficult problem to solve, especially in urban areas. Now, some of the main things that happen when we're out here in the real world is we have all kinds of obstructions. These includes buildings, vehicles, all kinds of objects, people, right, crowds, basically anything that we have in an urban environment is blocking or reflecting signals. And of course, in a non-urban environment, trees and mountains do a similar thing. And a lot of the core location technologies, GPS being one of them, need a direct line of sight to the satellites. Now, GPS is an amazing technology, but it was designed as a military technology in the 1960s. And it was never really designed, or never designed at all, for consumer devices to be used in urban areas, in and out of buildings. So although it's an amazing technology, it's operating outside of its design parameters. And by design, GPS has to have a direct line of sight to the satellite. And clearly you can't maintain that in an urban environment when you have all of these obstacles and obstructions. So what are the other options? Well, you'll see a lot of companies, especially Google and Apple, start to augment GPS with all kinds of other technologies. Cell tower signals were probably some of the earliest ones, or even before GPS, cell tower signals were some of the most coarse types of ways of understanding your location. But what Apple and Google did is they really started to extend that towards mapping out Wi-Fi access points. And basically they would drive cars around, record a lot of the Wi-Fi access point information, and use that to augment GPS and cell tower information. And they also pushed adding Bluetooth beacons, right? So basically trying to either use existing infrastructure or add a lot of new infrastructure. Now, early on, there was a lot of hype and excitement about having beacons installed. And, we saw a lot of our customers, even, shopping malls were experimenting with installing a lot of beacons, right? But in our opinion, that's not the right answer. Firstly, we didn't see a huge improvement in location. We still have a lot of location problems and errors. And secondly, in many cases, it's made the location worse because suddenly a beacon or a Wi-Fi access point signal would be picked up and the location would suddenly jump. And that's why we actually see a lot of these different jumps when we're using our smartphones. Secondly, and we saw this directly for our customers, a lot of customers, and such as shopping malls, started to become frustrated with having to add beacons, mount those beacons, right, fix them to walls or ceilings, power those beacons, and then having to do a site survey. So having to walk around, collect data, and essentially correlate that data to a map. So it started to become very expensive and cumbersome. And probably one of the more important issues was that generally whoever owned that infrastructure would not share that with other providers or users. So if a shopping mall ended up going with the expense of installing a bunch of beacons and maintaining those beacons, then they would typically not make the calibration or the data collection process that they use to translate that information into location. They generally would not share that with other carriers. So then it became siloed. And of course, that doesn't really make sense for smartphones or for all kinds of platforms that are not proprietary. And if you look at a lot of the applications that I mentioned earlier, a lot of these aren't on private properties, right? If you're delivering food or delivering packages or walking in the street or in and out of buildings, you can't just rely on some infrastructure that's been restricted towards a certain carrier or just that building itself. So from our experience, that's not the right answer, and it hasn't been proved right yet. And finally, the kind of last point I want to make, and this will eventually relate to my research a little bit, is a lot of these technologies are built on legacy radio frequency algorithms. And these algorithms can make sense when you have specific infrastructure under specific conditions. But when you have consumers using consumer devices in public areas, a lot of these algorithms have difficulty working. And one of the main reasons is the first bullet point here, which is buildings and other obstacles really blocking or reflecting a lot of that infrastructure. Okay, so what do we do at Navisense that makes things different? Well, firstly, we kind of started from scratch with a clean slate. If you were going to start a location company focusing on smartphones, you would then probably say, let's look at GPS, let's look at Wi-Fi access points, let's look at beacons. The history of Navisense, and I'll get into detail on that in the next slide or two, actually it was from my research where it wasn't based on smartphones. and it was actually based on tracking firefighters. Now, without getting into too much detail on this slide yet, the focus really for Navisense is using the accelerometers and gyroscopes that are inside your device. So these are motion sensors. They measure your motion. And, these days, every device has these sensors. And that includes smart glasses, smart watches, smartphones, tablets, basically anything electronic, especially if it's a smartphone or a smart device, has these sensors. So our focus is really on using the sensors that are inside your device rather than having you place sensors inside the environment. Secondly, we forego these traditional type of algorithms. And when I say traditional, maybe perhaps classical techniques, right? A lot of classical estimation techniques, which really rely on very expensive and accurate sensors, including RF frequency techniques that may not work that well in a urban area with consumer devices, right, which can move around unrestricted. Our focus really became on using, especially at the time, more modern, different algorithms. And our real focus is on using machine learning and a bunch of robotics estimation algorithms combined to achieve what we achieve. So it's a very different take on what happens when you try and do ranging and radio frequency measurements to beacons or Wi-Fi access points. And our goal is basically to give you an accurate 3D location regardless of the environment. And you'll learn in the next slide or two kind of how that worked out or why it worked out. But essentially what that means is anywhere you use your smartphone, whether it's indoors, whether it's outdoors, right, even underground, we want to be able to operate in that environment, which then leads us to the next point. Our focus is to have a software-only solution. So we never want users to install any hardware. We never want to force users to walk around and collect data also. We want a user to be able to get started instantly. And of course, the big advantage of that is now if you're a delivery driver or a delivery company, right, or operating in an environment that's indoors and outdoors and transitions between those different environments, you're not restricted by having to be in an area where you've collected data or an area that has coverage based on hardware that you've installed. All right, a couple of more screenshots here so you can get a clearer picture here. This again, it's a screenshot I showed a bit earlier, which was more of a thumbnail. You can see here again, GPS, which is in the blue color, which is really Google there, jumping around quite a lot. And then the red trajectory is Navisense, and that's exiting a building, nice smooth trajectory, similar to the trajectory that I showed with a user walking down the staircase. And here is another example, and this is actually a cool example that can show you just how huge some of these location and position jumps can happen. So this is a user exiting a building, and you can see the red trajectory there, which is Navisense. And you'll see the blue trajectory and jumping, and this is maybe a 10-minute walk where it jumped. There's a very, very large blocks here in the US. And a lot of the reasons why this happens is as soon as you go outside, if you're using traditional algorithms and if you're relying on GPS, you may have a sudden satellite or a signal that gets picked up, or maybe a Wi-Fi access point that may have been mapped incorrectly. And this causes these very large jumps. The big advantage that we have is that for us at Navisense, because we're actually measuring the motion of the user and the motion of the device, it's impossible for us to have this type of jump. But you can see here, if you were trying to find an address or find a spot to park in to make a delivery or even just to navigate around, this ends up being a huge problem. All right, so now we'll get into a bit more of the focus on kind of going from research focus towards a tech company, especially one that's based in the US. Now, to kind of understand maybe the background of how our technology evolved at Navisense, I'll tell you a little bit about my background. So I originally studied an electrical engineering degree, and in my E degree towards the end, I really started to focus on the technologies that are actually related to Navisense. Towards the second half, I started to worked with machine learning, which at the time was very early in its infancy. And the actual advantage here is that being at UTS, it was an elective that I studied. So it wasn't part of the core course at UTS. But the cool thing was, is I started to learn and experiment with machine learning. And at this time, it wasn't like today where you have a bunch of Python libraries and a million examples. It was a field that, you know, wasn't super popular. Maybe people didn't think it would be tractable and it would be possible to do practically. The resources that we had in terms of computing and memory power were a lot more limited compared to today. So I was fortunate to have been in the very, very early kind of days of machine learning, where it's very, very research-based, not mainstream at all. And also in my undergrad, for my thesis, I worked on a drone. And this was an unmanned blimp, or we'd call it a drone these days. And on that project, I got a lot of experience with inertial sensors, which are the accelerometers and gyroscopes, or the motion sensors, and GPS. And that was kind of my first taste in robotics and a lot of robotic sensors. So it was a really great opportunity. And based on that, I actually ended up going straight into a PhD and got a scholarship and was at the UTS Robotics Institute. And that's really where a lot of my research and robotics background developed. Now, the cool thing is at the time we worked on, you know, the UTS Robotics Institute, or what was CAS at the time, you know, wasn't just one of the leading research, you know, groups in Australia. It was one of the leading groups in the world, and we had a huge amount of projects. And during your PhD, I spent some time, or during a PhD, you usually spend some time experimenting and getting exposed to a whole bunch of projects. And that's where I ended up focusing on a lot of automotive style projects, you know, assistive healthcare projects, a lot of sensing, you know, GPS, cameras, pretty much anything you can think of. And, you know, eventually I even ended up with a group from UTS where we spent some time at UC Berkeley working on the DARPA challenge, so the very early autonomous vehicles races. So we got to have huge experience in robotics. And when focusing on what I was going to study for my PhD, or the topic that I was going to choose on my PhD, a lot of people, or a lot of other students, were focused on mobile robots. What I decided to narrow down is to work on the localization problem. So finding the location, you know, of a robot or an object, or whatever it may be. But instead, I decided to focus on tracking people, or more specifically, tracking firefighters. Now, you might think, you know, what's the challenge, or what's the reason for doing that? Well, you know, if even today, for the most part, when a firefighter goes into a building and they get disorientated, or they have no idea where they are, or their radio goes out, no one actually will know where they are and can't come to their rescue. Firefighters really rely on using communication and using their radio to relay where they are. So it was a problem that was actually a problem that was would have been useful to solve, has a potential to save many lives, but also was an extremely challenging problem. Firstly, a fire is unpredictable. So we couldn't go to a building and say there's a fire at 4 o'clock tomorrow. Let's come in at midday, install a bunch of sensors, right? Put, you know, cameras everywhere and beacons everywhere, right? You really can't do that because you don't know when a fire is going to happen. Secondly, even if you could afford to install sensors in a whole city, in everyone's apartment, in residential buildings, houses, commercial buildings, when a fire happens, all of that infrastructure ends up burning down, right? Power gets shut, the sensors burn. So even that isn't a feasible type of scenario. And then finally, for a firefighter, generally you can't have a setup procedure. So you can't turn up to a fire and then do these scans or collect data. You kind of have to start instantly. So it's actually quite a challenging problem to solve. And secondly, a human isn't like a mobile robot or a vehicular platform where you have a platform where you can mount sensors and lasers and cameras on there, and a platform that's stable, or a platform that you actually can control, right? A human isn't like that. So it means you're actually quite limited by the type of sensors that you can mount on a human, right? It's impractical a lot of times to have cameras, right? You can't put LiDARs and sensors, and the human isn't stable. You can't have batteries or large heavy equipment. So this actually made things quite a lot more challenging. Now, given the robotics research and the background that we were doing at UTS Robotics Institute, a lot of the applications I worked on, one of the commonalities of those applications is we used what's called an IMU, or inertial measurement unit. And essentially, it's a group of motion sensors that are combined in one package. And these sensors we use in all kinds of robotics platforms. Every autonomous vehicle today uses those. Aircraft use them. We use these on assistive wheelchairs. We pretty much use these on every type of application we worked on. The problem is a lot of the traditional algorithms that use these devices use these traditional type of classical techniques that required very accurate devices. So for the autonomous vehicle that we worked on when I was at Berkeley, it was a $20,000 IMU, and it was a huge, large unit, very heavy. That's impractical to use on a human or a firefighter. So my focus really became on using these lower cost sensors that were coming out at the time. They were called MEM sensors, or micro electromechanical systems sensors. These sensors are now in every smartphone, every wearable device. The biggest problem with these sensors is they were built, for very high volume, and they have a lot of problems with errors and noise. So using the classical, traditional type of algorithms and techniques really didn't work, and it would completely fail. So in my PhD research, my focus was on using robotics estimation techniques combined with machine learning to really come up with a hybrid approach, which then can counteract a lot of the large errors that we would have in these lower cost sensors. Now, at the time, it was a wearable device that I focused on. It was actual hardware that I had built. But now when I really focused on building a tech company, this really transitioned into a pure software piece of software, a software development kit that essentially we license out to developers for iOS and Android. Now, to kind of get to the startup point, my real focus, even, during my PhD and before that, I always was interested in starting companies. And during my PhD, the more I learned and used GPS and the more I learned about the background of the technology, as an engineer, I was actually, inspired quite a lot about that. GPS is actually quite an amazing technology, especially for the era that it was designed, which was in the 60s. And internally, I really thought I want to be able to have the same impact around the world, in terms of saving lives, commercial applications, whatever it may be, as GPS. So that really kind of led me down the path of saying, I really, to have that kind of impact and to be able to grow and scale and move quick enough, the best way to do that is really to transition this into a tech company. And that's really how Navisense ended up coming about. Now, I'll explain a little bit more in the next few slides about the process and kind of my thinking behind how that worked out in the US. All right, so this is a slide or a screen cap from a news article that wrote about me actually in Australia, the Financial Review. And I think it's a typical kind of story that we hear in Australia, right? A lot of Australians moving out of Australia, looking for opportunities elsewhere in the world, especially for people who come from an engineering or technology background or start companies. And essentially, this was a similar story to me. So what I want to do today is I just want to go through a few high-level points to kind of similar to if you're coming from a research background or if you're in Australia, why do this or why focus on moving to the US? Now, it is true that there's a lot of opportunities in the US, but it is a tough transition and a lot of work to start a company here and move to the US. So there really has to be a good reason why. From my point of view and how I think about things, there's probably 3 or 4 different things. I'll get into a little bit more detail on each one. One, probably the most obvious one that everyone hears about is Silicon Valley or San Francisco. You think about the community, the groups of people, the energy. So that's definitely a big reason, right? There's a reason there was a very strong congregation of engineers, technologists, CEOs, companies that have been started here. Secondly, it's to be in close proximity to your customers from a sales point of view. And I'll dig into a little bit deeper about that. Raising capital, that's one that always gets brought up to me, especially from Australians. And it is definitely true that in the US, there's a lot more appetite for risk and it's a lot easier to raise capital, although it's still hard. But for me, the main thing is where do you want to position your company? And that really is what stems for me. So if you think about it, to give an Australian example, if you're building a mining technology company and you're going to be focused on the mining industry, it would probably be silly for you to come to the US, right? Your smartest thing would probably be to open up headquarters in Perth in Australia and really focus on having your operations there, right? You'd want to have a team there. You'd probably want a sales team there to meet in person with all of your customers, because that in-person approach makes a very important difference, especially for large enterprise deals. You probably want some engineers that are based there or in close proximity so they can fly down and fix any problems or debug issues. So to me, that's the main reason why. And from a tech company perspective, when I say position the company, for us, we think, who would our biggest customers be? Is it an Amazon? Is it an Uber, right? And if it's those types of customers, right, is it a Google or an Apple, Intel, any of these types of large tech companies? They're the types of companies that we were targeting, or that would be our ideal customer. You know, the only way to get deals done with those companies, not the only way, but the best way, is to be right next door to them. And to me, that's the main reason of the decision maker of whether you should be in the US or not, or what drives people or drove me to be in the US. It's where I wanted to position the company from all kinds of points of view. But it's really to be close to our customers, whether that's to sell to them, whether it's to get acquired by them, right? Whether it's just to let them know that we exist, because sometimes it might take a year or two of meetings or for them just to randomly bump into you and then to hear about you. So to me, that's the main or the most important reason. It's where you want to position your company from, either, you know, your customer point of view, or just from the life cycle of that company, and from and so customer sales and the outcome that you'll get. Probably the second strongest reason for me is the community. There's a very strong tech community here in San Francisco. You know, the story of how I started my company, you know, and you'll see it in this screenshot here. It says, but I was literally, you know, when I first came here, I wanted to tell everyone about what I was doing, but, you know, I didn't have any capital raised. I was, you know, a poor student from Australia, a poor PhD student, and I did anything I could. And I slept at, you know, a couch of a colleague or a friend that I met when we were at Berkeley working on the DARPA challenge. And it's by chance that I ended up just walking out of there and going to a networking event that I bumped into a guy called Jason Calacanis, who I had no idea who he was at the time, but is a well-known tech personality, investor, you know, a very well-connected and successful person in tech. And, you know, I literally physically bumped into him. He asked me what I do. And based on that, I actually ended up getting into an event that he hosts, which is called the Launch Festival. And if you actually go on YouTube and you just Google Navisense or Ashod Donikian, you'll come across my first ever live presentation and demo, when at the time it was still hardware. It wasn't a software product. It was a hardware and software product. And, you know, that's the kind of magic that happens here, or that can happen here. Of course, it doesn't mean it can happen to anyone. You still require a lot of hard work, but provided you work very hard and you're excited about what you're doing and have a lot of drive, those types of things really can actually happen here. And it's quite different to Australia. So there's a great community. It's also a community that has an appetite for risk. So if you explain to people what you're working on, people are excited about it. They want to help you with it. And even if they understand that it may or may not work out, that's okay. It's just part of the actual journey and what we focus on here. And then finally, there's the capital raising. Now, although it's never easy to raise capital, it is definitely a lot more accessible here, especially at the time that I came to Australia. You know, it's a very large difference between being able to meet investors here and really, you know, have a process of how you're going to raise money. And that's usually the first thing a lot of people ask me, but I think it's actually should be lower down the list of the other points that I mentioned. And now I'll try to run through some of these a little bit quickly so we don't go too far into our time. So I guess after that kind of explanation of why you would come to the US, you know, the kind of first thing you really have to do is find out, how do you get your first customer? And, you know, from a research perspective, we never focus on sales. We never did any sales. You know, we worked on some industrial partner projects and customers, but we only focused on the engineering side. The cool thing is, I actually think it's an advantage to have some naivety and lack of experience. So for me, I started to think, you know, what would be the best industry to get into or best customer to focus on? I focused on firefighters. I quickly realized that it's, with government spending and public, funding, it's very difficult to sell to them. And also there's a very high bar, for safety. You have to make sure a device is tested and reliable. So I quickly decided that that's not my first target market. At the time, I noticed especially, and this is still true now, there was a kind of war between bricks and mortar retailers and the online stores, especially Amazon. And this kind of became my point of focus. And my goal was really to find a customer. Being a small company, initially just myself founding the company, and then, eventually hiring 2 other engineers, so 3 people that no one's heard of, with a product that's not mature yet or has hardly been tested. I really wanted to focus on a customer that could understand our problem, that I wouldn't have to convince them that it was a problem. And that's where I kind of came across shopping malls and retail, and especially with all of this pressure on them, to really come up with a way to show their shareholders and their customers that they have a solution and people should still come into stores. And that actually became our first customer. It was one of the world's largest shopping mall operators. We were 3 people total at the time, all engineers. And we didn't even have an SDK yet. We had never even tested our technology on iOS. We only had an Android version. But these are the kind of things you do when you run a tech company. You kind of really sell first, and then you work out how to solve the problem after that. But the cool thing about having, or the important thing about having a first customer, and I have one more slide after this about fundraising, but it gives some validation, especially if it's what we would say like a large logo, right? So if it's a large customer where you can place their logo on your website, it validates this product or technology for other large customers, which, although large customers have a lot of capital, they're generally very risk averse, long sales cycles, and it's difficult to get on their radar. So that was my approach towards really getting our first customer in sales. A little bit before we get into fundraising, a lot of people ask us what we focus on today. We have a lot of hospitals, healthcare facilities. So generally we focus on a mix of indoor location or outdoor indoor location. So hospital and healthcare facilities are some of our large customers. We have large companies that want to navigate or understand where their workforce is in large buildings. That kind of went on pause or on hold, especially during COVID, and now it kind of is focused on reopening workplaces. We have a bunch of augmented reality customers. At least Bose is one of the ones we can publicly mention. They have these smart glasses that they call the frames. Now, in augmented reality, typically you would use a camera. That's how a lot of the traditional augmented reality technologies are based on. Although we don't use a camera, the advantage that we have is it works on very lightweight devices that are low power, or they just don't have a camera for privacy's sake. So the Bose frames are smart glasses that are audio only. They have an IMU inside, an inertial measurement unit, but no camera. So at least when someone's wearing them, you're not worried about being recorded. And of course, Apple, their their headphones. Again, no camera, low power. You want them to last all day. So that's our focus on AR. Defense. We've been in defense for a little while, and the main focus there is tracking when GPS is either jammed or not available. And kind of the most recent and I would say the largest scale of that is last mile and deliveries. They're very high scale, high volume type customers, and I would say probably the largest potential of scale for location. But I'll briefly touch on fundraising with some quick things that I kind of learned here. This is an article from a few years ago when we raised our first venture round. We've raised additional capital since then. We just haven't, which we haven't publicized. Now, when I first came here, and a lot of people are excited to really help you, and everyone's kind of says, "Hey, I can introduce you to this investor or this VC." And I think kind of from a process point of view, the first thing we need to know as engineers is you really have to have a working prototype or something you can demonstrate. As engineers, that's probably natural to us, coming from a research background. But that's not always true. You don't want to have just you can have maybe a lab prototype, but ideally you have something that you've built and you can demonstrate. It may not be pretty, it may not always work, but you really need to start off with that. And having traction never hurts. And traction could mean you already have a customer, they may or may not be paying, you may have a bunch of users, right? Whether they're paying or not doesn't matter. but having some kind of traction or growth or number that is growing, or you can show that as some usage, is great. And then finally, you really need to focus on the right investors. I remember when I first came, I wasted a lot of time having meetings with very, very large funds. And if you think about it, if you have a venture fund that's $1 billion fund, and if they're only going to put in $1 million or $4 million or $2 million into your company, the percentage of that of their entire fund of capital is just so small, it doesn't make any difference to them. Now, they'll happily take the meetings with you, but it's not the best use of your time. And generally, it wouldn't be interesting for them to invest. So you really need to focus on, firstly, angel investors. And I actually raised our first round, which is $500,000 from angel investors before we went to raise from venture capital. And then you just need to have the right process for fundraising. And there's kind of, I won't get into it in this video because it's a lot of information, but there's actually some ways that we approach the fundraising process of who to target, how to get introductions to those investors. And for that, again, we leverage the community here, which is a very kind of tight-knit community. Finally, I just want to say, there's different reasons for fundraising. One is, of course, it's great to have capital to just get started and especially to grow. But there's another reason, and one is for customer validation, especially for us where we deal with larger enterprise customers. A lot of them are risk averse, and they either get worried about you not having the capital to be able to fulfill your obligations of whatever the deal or partnership is. And secondly, there's, especially if you're not well known, they're unclear about whether they should deal with you. Now, raising money from venture capital, usually VCs might invest in less than 1% of companies they see, and they might see hundreds of companies a year, or they might get thousands of emails from entrepreneurs and founders wanting to start a company. Most of those either go ignored or maybe last a meeting or a phone call. So just the fact that you managed to raise venture capital is a high bar that's telling a potential customer that you've gone through that vetting process of somebody who might see thousands of entrepreneurs and companies. All right, so what's next? Just very briefly. So you may have heard of, really what we want to do is build a location platform where it abstracts a lot of the complexities of location and allows developers to build APIs to build applications. So, we kind of position it as a Stripe for location. And if you've heard of Stripe, it's a payments company API, which makes it super easy to get started. And they've grown huge because it's actually just a great product, removes a lot of the complexities of accepting customer payments and narrows it down to some simple APIs. Essentially, that's what we're doing at Navisense. We're always focused on technologies. Our engineering team is 50% research, 50% software. We recently just released a web SDK, so tracking directly in the browser without having to download an app. That's built with WebAssembly. It's super cool. So as an engineer, we love these kind of things. Building mapping APIs. So when you have thousands of people entering and exiting a building, whether that's for deliveries or ride sharing or whatever it might be, you actually start to get a pretty good understanding of the layout of the building. So really providing that to customers, focusing on scaling the mobility and last mile tracking, which is really the largest potential customers, and then going to raise our Series A and kind of more capital and kind of growing from there and continuing to accelerate. All right, well, I'll wrap it up there, just a little bit over time, but I think that covers pretty much everything I wanted to chat about.
Okay, thank you very much, as for the nice story sharing. So it's time for questions. Anyone has questions, you can just speak out, or you can raise your hand or type it in the chat. Yeah, Jaime.
Hey, Ash. Just a quick question on the side of the setting up the company. When do you draw the line to actually make money, and investors start to get less anxious about it? How does it work?
So in the US, there's less of a focus on making money. So if you remember, I mentioned in the fundraising tips, having traction doesn't hurt. And by traction, it can be really anything, right? It could be traction as in like customers, right? Customer payments. So traction could just mean you're getting, $1,000 a month from a customer and you're growing those customers 50% or 30% month over month, that's great traction, and you're actually getting revenue as well. But it could just be, traction as in you'll have a free model, or you're not even caring about accepting money, and you're just focused on getting customers. Now, generally, there's less of a focus on the revenue side and more of a focus of the growth and growth potential. So you're better off having a company that, say, grows 30% month over month in terms of users, right? Whether it's users downloading the app, users using the app every month, like monthly active users, or whatever it may be, but you're better off having a metric that grows as much as you can, close to exponential, than raising any money that you may actually have as revenue. So generally, that is the priority, and most investors in the US, at least, if they see growth like that, they know you will one day, hopefully, you'll one day work out how to convert that into actual revenue. Because it's much harder to have something that's growing at a crazy amount than it is to just get revenue from customers. So they focus on the growth a lot more. But in general, it's just to kind of summarize that, there's no real huge pressure. But once you do have that, though, it frees you up from being tied to investors as much, because the typical startup kind of journey in the US is you continue raising and raising and raising and raising more and more and more money. And at some point, you've raised so much money that the only outcome for a company, if you don't have revenue, is to get acquired. And if you've raised way too much money, that really narrows down the number of companies that can acquire you, unless you want to go on to be a public company. But that's another story altogether. And it's a very small minority of companies that should or even manage to become public companies.
Nice. So you got an easy life then, huh?
If maybe easy and hard, many ups and downs.
All right, and sorry, one further question. I don't know whether there's anybody else in there, but what about competitors? I mean, I do know that there is actually quite a few people doing, mobile localization. Not just, you talk about Google, but some other smaller partners, basically, like such as yourself. Who are the other partners? Are they really? I don't know. What's your opinion of them?
Yeah, so there are actually quite a lot of companies, or there used to be a reasonable amount that focus on location. Generally, to me, I focus, the biggest separation with most of them is infrastructure or non-infrastructure. Our focus, just because, it originally started, especially from tracking firefighters, where infrastructure, wasn't an option. Our focus has always been, we don't ask you to collect any data. We don't want to have a map. We don't want you to walk around collecting signals. We don't want you to install sensors, right? A lot of other companies, their approach is infrastructure first. So it says, if you don't have any sensors, we can't do anything, right? And then to actually have an accuracy that is reasonable, you have to have, a sensor every X amount of square meters, right? The problem with those companies is it was almost like every company was doing the same thing, Wi-Fi access point mapping or beacon mapping. So that's, I would say, the biggest differentiator between us and those companies. Finally, for us, we've kind of become agnostic to the application. We don't really say this is built only for a specific application. We've tried to say, it will just replace your, iOS or Google location. Some companies, and this isn't a good or bad strategy, it really depends, have said we're only focusing on, say, deliveries, right? Or we're only focusing on healthcare and hospitals. So that's a different kind of approach. We've tried to stay as open as possible. And that's probably the two biggest differences, I'd say, in location companies. But for us, having an infrastructure focused approach, where I'm not a big fan of that, and that's the direction I've kind of generally taken Navisense. It can apply great, but that's either like shopping malls or hospitals, and most of those companies will have, say, a setup fee where they come, install the sensors, collect data, and then charge, say, a hardware maintenance fee. Or the opposite, we say there's no upfront costs, you just pay a monthly fee. So different strategies.
Okay, Gavin.
Hey Ash, I just joined from my computer so I could be on my camera. See you. It's good to see you again.
Likewise.
Really, congratulations. It's great to hear that you still got runway and that there's still some capital flowing in and you've still got a team that you're building and you got some customers. I wonder if you could speak to the non-entrepreneurs, people who are thinking about perhaps moving to Silicon Valley to get employed? Because I know that when you were sleeping on the couch, you're probably thinking this may fail and I may need to get a real job at some stage, even in one of these startups. And I know you've employed some people who we know. Could you speak to the opportunities that are available to PhD graduates, both in Silicon Valley and in and around your space?
Yeah, sure. So firstly, when I was sleeping on the couch, never in my head did it come that I'm going to get a job. It was just, it's kind of like failing is not an option. So that thought didn't even come across my mind. And I think that's how you kind of have to be as an entrepreneur when you're starting a company. You kind of don't even think, for good or bad, you don't really think about any other option. But definitely there's a huge amount of opportunity here. So firstly, even without a PhD, just in general, we're very lucky that Australia has an E3 visa, which makes it very easy for you to be employed by a US company. It takes, I sponsored it before for Australians. It takes maybe 2, maybe maximum 3 weeks to get the visa done. And especially having a PhD, you show that you have specific knowledge that is not common to have. And you're not just taking a job that anyone can do. So having a PhD or research background coupled with the E3 makes it super, super easy for anyone to hire you, which that's generally the biggest hurdle. You don't have to apply for a lottery system type of working visa. So that's, I guess, the first thing. Now, these days, so it's funny, when I first was here, I'd never, the only time I'd hear the keyword or the word SLAM, right, or simultaneous localization and mapping was in research. I'd never hear it. Now these days you hear a lot of people say, oh, are you guys using SLAM, right? Because it's become, there's a lot of robotic stuff that's quite popularized right now, mostly for augmented reality and machine learning. So these days you should be able to find quite easily a really good position here, especially with a PhD. And I would go for any of the autonomous vehicles companies, space related companies. You can always go for any of the big companies, Google, Amazon, Apple. A lot of them actually hire a lot of researchers. So I think there's great opportunities here. And career-wise, I think it's a big advancement. Very different to academia though. And you work in large teams and sometimes chaos. Even at some of those large companies, but definitely great opportunities. So if you're interested in that, I think the main thing is you let the employer know that you can get an E3 visa, which is a piece of cake to get.
Okay, good. Leah, you have a question?
Hi, Ash. Nice to see you again.
Likewise.
If you remember, I was an exchange PhD when you, I think just before you graduate.
Okay.
So my question is quite close to what Gavin asked. For our students, PhD students especially, in CAS, or we call it Robotics Institute, if they want to work in a high tech company like yours, what do they need to, or is better to be prepared during their PhD, or they focus during their PhD? Because I think you graduated from us, and you're the boss. You're hiring like engineers and scientists. I think that's the best advice that you can give us, our PhD students.
Okay, so this is actually a really good question, and I think many of us engineers will understand. So when I was doing my PhD, most people coded in MATLAB, right? Everyone would do MATLAB. Because I had an electrical engineering background, and because I built a lot of the hardware, my code was part MATLAB, part C++. And eventually 100% of my code is in C++. And at Navisense, actually all of our code is in C++. Now, when I first started here, most of the engineers that I hired, especially PhD level, master's or PhD, or anyone on research, that we bought MATLAB licenses. So they would use MATLAB. These days, we don't use MATLAB at all. Everyone, especially recent hires, all use Python. And at the time, Python to me was kind of like the poor man's MATLAB, the poor person's MATLAB. But actually now Python, I would say, is more important. Maybe unless you're at NASA, or even NASA, Python is important, but some very, very scientific focus. I would say at a tech company, Python is much more important than MATLAB. And it's similar to when I mentioned a lot of the machine learning, for example. When I started in machine learning, I wrote it in C++. There was no big libraries, no easy examples. Today, if you're going to do anything in ML, you just start in Python. You can easily visualize data. So to me, what I see in the research applicants, not academics, but including PhDs that I've hired though, that decided not to continue in academia. As soon as they graduated, they applied for us. They all really loved Python. So I would say, I think it's a plus to be familiar with Python. And I don't know these days in research if you guys are using Python or still MATLAB, but I think Python is a plus. And I would say if you're going to do anything autonomous vehicles or anything that has a real-time element, real-time estimation and programming is quite important. I know a lot of people would play back data sets and you can wait, we go for lunch, come back in 1 hour, and then maybe we can see a result. I think the real-time side of things is quite important, especially if you do C++. Depending on the type of company you apply for, it's quite an advantage. And then I guess finally, I would say it depends on the problem. I always, so to me, when I interview engineers and I tell people this advice, I always think the last project you worked on tells me about your interest and drive. So if you're undergraduate, and I would look at your undergraduate thesis, right? And if you're a PhD, I would look at your PhD thesis. It tells me a lot about yourself and the type of things that you find interesting. So I always think the problem, it doesn't have to be the same as the company, but it should be something kind of interesting that interests you and you're continuing to do. So I think that's not 100% has to be exactly, but I think that tells me a lot about you. So that's why I think as a student, don't just choose a topic your supervisor says, but you should choose something that you think is really interesting.
Yeah, sure. Thanks, Ash. Thanks.
Yeah, that's a good advice. Leo, I think is also here.
Yeah, sorry, I don't have my camera in this PC, so I just verbally asked my question. First of all, thanks for the impressive talk. I actually followed your path and came to the US, joined Amazon. So thanks for mentioning Amazon multiple times in the talk. So I have a question that how do you handle the risks associated with the innovation? Like how do you balance the investment versus the outcome?
Okay, so I will give you the non-Amazon answer or the non-big company answer. The startup answer is there is no balance. It's all entirely a risk. That's all how it is, especially at the beginning. But the thing is it's kind of what I tell my team when we are planning on something, and we don't know if it's going to work. At the end of the day, we're still using our skills and experience to design and build something. It's not like we're doing magic, right? So we have some understanding of what we're doing, and our theory is we think it can work, or if it won't work in how we're thinking, we will find a way to get it work. It's still risky, of course, but to me, it's still, at a startup, these things are tied together. So it's impossible to lose one without the other. I think maybe for very large companies like Google or Amazon, where they have so much revenue, even you see like for them, doing autonomous vehicles, even though it's a lot of capital invested, the outcome is nothing compared to how much money they make from advertising, for example. So for them, it's a very, very different risk profile, but for us, the risk and the innovation are part of our business. That's inherently how it is. And you can't separate them. I think unless you at some point, you have a very, very stable product, kind of like Microsoft, where they have Windows, right? You can do anything, but Windows will always be there. So you don't really have to take any risks, or they're too worried about taking risks to ruin Microsoft Office or Windows, right? But yeah, for a startup, I think it's very hard to separate those, and probably they shouldn't be separated, because otherwise everyone will have too much of an easy life and you don't have any pressure or risk.
I see. Thanks.
Sure.
Yeah, any other questions?
I think there's a chat, Shudong. Is that right? Oh, sorry, that's you actually writing in there.
Yeah. No. Yeah, maybe I ask you a question. What's your strategy to keep good people within your company? And apart from paying more salaries, do you have any strategy for keeping them?
Yeah, so firstly, no startup will ever compete with big companies, you know, Amazon or Google in this in salary. And if that's the reason for somebody to join your company, then probably there's somebody you don't want to hire. You know, so I think as engineers, the most important thing is to be working on an interesting problem. So I think we need to be stimulated, right, by the problem we're working on. So we want to kind of be excited about it, to really, you know, sometimes the best thing for me is I have a problem I can't solve. And then I think, and I'm like, oh, let me try this. And I get very excited just to try it. I think we have to have stimulating items or things that they're going to work on. Secondly, you want to give them enough freedom to be able to be creative and to do whatever it is they like. You know, so for us, I always told anyone, if they see anything in the code that they think is wrong or can be done better, or they think it's stupid or they want to change it, they have complete freedom to change anything they want. As long as it performs at least equal to what we already have, if not better, then it's a good change. You know, so that's the bar for like improving some things, but they have complete freedom to do that. But at the end of the day, they focus on, I think the keys is to focus on something that they still find interesting and stimulating. That's why for us, it's still quite research-based, you know, and there's many interesting things that we're doing that a lot of engineers will find stimulating. Finally, I will just say on the hiring process, usually when we go through our hiring process, we give a lot of projects that are related to what we actually work on with real data. And we usually find when people apply for our company, even if we don't hire them, they actually really enjoyed the project, because it wasn't like a project, write a Kalman filter to solve something, right? We may not use that, or it might be a project from a textbook. You know, for us, it's a project with real data, and we've solved it in one way. We ask them, we don't tell them how we've solved it because it was already very challenging and they probably won't do the same thing or won't be able to, but we just see how they will solve it. Even if they couldn't solve it, we look at the procedure they did or the process they did. And in our feedback is a lot of people really enjoyed that because they could see it's real information, real data, and a real problem. And then they might say, this is too difficult, or we're not interested, I don't want to work here. Or they might say, wow, like this is really great. I couldn't solve the problem, but I have some other ideas if I had more time. You know, so I think it's a bit of everything, but for us, it's still a very engineering focused process, which is what I like.
Okay, if there's no further question,
I just one sec, Chudang. Hi,
Yes,
Ash. This is Saratya. How are you doing?
Good. How are you doing?
Great, great. Apologies, I couldn't join this your talk because this faculty is there's a workshop happening and now is the lunchtime, so I just dialed in. So thank you very much for taking the time to join us today. And I'm pretty sure it's a brilliant talk. I used to hear your talks with very enthusiasm, and I know that this your recording is going on, so we can have a good look at it afterwards. So anyway, thank you very much for coming on board and giving us you know, insight into what you have been doing, and I'm hopeful that you might have talked about how the process of being student to now a CEO of a company, how it looks like, and you know, the experience associated with that. Just to say thanks again.
Thank you, Sarat. Thanks for having me.
Right.
Yeah, so we really hope you will come back to Australia and we can meet you and maybe have a more detailed discussion between you and our students.
Sounds great. I'll buy the first beer, Ashod.
We need more beers than that, Ash.
Take your word for that.
Yeah.
I'm paying in US dollars, so it's a bit better.
Yeah, this is a bit better now, I guess. Yes.
Okay, thank you very much, Ash, and thank you for
Thanks, Ash. We'll see you soon.
Thanks, Ash. Thanks.
I think it's a very
Well done. It's good, good talk. Thanks.
Thank you. See you.
See you guys. Let us know when you're coming this way.
Will do.
Thanks.
Okay,
okay,
bye-bye.
thanks everyone. Thanks.